We have another talk coming now. Sylvia Earle does it all. She's a marine biologist, oceanographer, explorer, author, and lecturer. She's long been a National Geographic explorer at large, was the first female lead scientist of the U.S. National Oceanic and Atmospheric Administration, and was named by Time magazine as its first hero of the planet in 1998. Today, Sylvia will describe a fascinating subject, exploring and protecting Earth's deep frontier. Please help me give a big welcome to Sylvia Earle.
What a pleasure it is to be here and to think blue. Without the blue, there could be no green, no blue, no water, no life, no us. There's plenty of water elsewhere in the universe, it appears, but nowhere, as far as we know, is there water filled with life. So, the ocean, why should anybody care? What's the ocean ever done for you? You could ask that question, especially if you've never seen the ocean, if you've never touched the ocean. You might not realize that with every breath you take, every drop of water you drink, the ocean is touching you. All life, again, as far as we know, life as we know it, requires water. Those looking for life elsewhere in the universe, what do they look for first? Where's the water? Well, here on Earth, 97% of the water is ocean. So it should come as no surprise, but it is for some people who haven't thought about it. That is where 97% of the biosphere, where life actually occurs. It's in the ocean. It's a three-dimensional space. We look from the top, from the sky above, from ships, from the shore. But what do we know about what's under the surface? Literally, in my lifetime, more has been learned about not only what's under the surface, but why the ocean matters to everyone, everywhere, all the time. And we're learning that the ocean is changing. Like so many of the talks you've heard this morning, look in the mirror. We are the agents of change. Yes, it might be tempting to go set up housekeeping on Mars. And as Stephen Hawking suggests, that maybe we will so damage our own blue planet that terraforming Mars might someday be a necessity. But I agree with the comments made earlier that if we are to terraform Mars, we'd better stop Marsiforming Earth first. Here we are. The atmosphere of Mars has a lot of carbon dioxide. We're putting more carbon dioxide into our atmosphere that once upon a time had a lot, but owing to the action of life, we have an atmosphere that is very different from the Earth's early atmosphere. We are the beneficiaries of 4.5 billion years of fine-tuning rocks and water without life. now with a planet that is habitable for creatures such as we. Scientists at Woods Hole Oceanographic Institution did some calculations, and they came up with this graphic image of how much water there is on Earth. 97% of it, at least, that's the ocean. If you spread it around in the basins around the continents, the average depth is actually 2.5 miles, about 4 kilometers. It doesn't look as though it would go very far, but actually, that's what keeps Earth from being a lot like Mars, that water plus life plus 4.5 billion years. So, it's only taken us about 4.5 decades to quickly change the nature of that amazing body of water. I was first drawn to the ocean when I was about 3 years old. A wave actually knocked me over, got my attention, and it's had my attention ever since. Water, a magical substance that occurs as ice, as vapor, as a liquid, and as ice, it has such an important role in terms of shaping the planet in our favor in current terms. The polar regions that are a dominant feature in terms of shaping current climate. Now we know, mostly, knowledge that has been gained in the last half century or so about how the ocean really governs climate. It isn't just a physical phenomenon of temperature. It's a biogeochemical phenomenon with an emphasis on the bio that sets Earth apart, as far as we know, from any other place in the universe. Water plus life is shaping Earth as a habitable place for us and the rest of life as we know it. It's not just temperature that governs Earth as a habitable place, temperature within a certain range. It's the chemistry of the planet. Again, that has taken a very long time to get to where we're at. And it's life that is involved in every process. We can measure the physical and chemical characteristics, but when you peel back the layers of what makes Earth unique, it's the existence of that magical thing we try to define. It's life in its many variations. So, you may have heard of Johan Rockström. He's among the scientists, and we'll hear from more at this conference, who are concerned about our impact on the physical, biological, and chemical nature, the biogeochemistry of Earth. And here we are in what some are referring to as the Anthropocene, our capacity to alter the nature of nature in ways that do not favor our continued existence if we continue on the track that we are currently on. And looking at measuring, what are the boundaries that we need to stay within in terms of the temperature, in terms of the level of carbon dioxide, in terms of the impact on the diversity of life. You can measure some of the factors that we are now exceeding in terms of keeping a safe place for the likes of us. Imagine if we did not know. That would be a problem greater than what we now face with knowledge. Kids ask me sometimes about how a sense of despair about their future, about what they can do as individuals. And I say it to you, imagine if we did not know the problems we have. Be glad you are a 21st century human being armed with knowledge that not only did not but could not exist not so long ago. 10-year-olds of today have knowledge that not only I as a 10-year-old, but nobody could know. No one had been high in the sky to look back at Earth. No one had been in the depths of the ocean to really see that life exists from the surface to the greatest depths, to understand the role of the living planet on the rest of what makes Earth habitable. I started out as a botanist, and I started diving right in, looking at seagrass meadows and seaweeds in the Gulf of Mexico. With those qualifications, as one of the first blessed with the ability to have access to scuba. 1953, in the United States, it was considered a scientist using scuba could not be taken seriously because surely you must be having too much fun. And actually, I was having fun and was also chosen to be able to go as a botanist, diving botanist, on an expedition in the 1960s when it was unusual for women to have access to the sea on research vessels. So I was among 70 men to go on a 6-week expedition to the Indian Ocean. I thought nothing of it. I was a scientist, but when interviewed by a reporter in Mombasa, the question was not, what are you going to do there as a scientist, but it was, Sylvia sails away with 70 men, but expects no problems. The only problem that I think I felt at the time was the same that scientists still feel. How do you understand the ocean when we are terrestrial, air-breathing creatures? On our expedition in 1964 to the Indian Ocean, we were armed with much the same kind of equipment that the Challenger scientists used in the 1800s, 1874. Lowering nets, lowering hooks, dredging, bringing dead samples back to the surface. Imagine if Jane Goodall had to understand the chimpanzees of Gombe using standard oceanographic techniques, trying to hook a chimpanzee from high in the sky, not even seeing what was in the forest below. So much is now known that could not be known in times prior to the present. We have the capacity to look at our blue planet with new eyes, new insight, new information. That is, I think, the greatest reason for optimism, for hope. It's what we now know that we could not know before, that we are the agents of change. At about the same time that the first footprints were being put on the moon, for the first time, people were able to live for, a short period of time, not years, the way scientists on land can take for granted. They can go camp in the forest. They can go and stay in polar regions and spend years studying. But underwater, it's a gift even to have an hour at as much as 30 meters. So when I had a chance as a young scientist to answer an invitation to submit a proposal to live underwater for 2 weeks, underwater, staying underwater, like going up into space, in the space station for a period of time, I couldn't resist. And I was one of those selected. But again, it was considered inappropriate, as it was in the early days of space exploration, for women to be part of the action. There were astronauts on the moon in 1969 and 1970, when I became one of the small number of women, 5 of us, who jumped through the hoops necessary to become aquanauts, you know, but they didn't call the women's team, of the 10 teams that were otherwise just male, they called us the Aqua Babes, the Aqua Chicks, even the Aqua Naughties. And I wondered what the astronauts would have been called, or how they would have thought if they had been called Astro Hunks or Astro He-Man, who knows. We did not care much what we were called, just so we could go. And it wasn't just the experience of living underwater, it was actually the experience of being outside, using our little underwater capsule as a place to eat, sleep, take a shower, write up notes, look through microscopes, but mainly the joy in the 10 times that I have been able to live underwater for extended periods of time. It's getting outside in the ocean. This would be called by astronauts extravehicular activity, the EVAs. But underwater, that's the point. To stay inside, you can look out, the fish look in, but to be out and use the ocean, the living ocean, as a laboratory, that was the gift that I enjoyed. It changed me, just as astronauts are changed by the experience of being high in the sky, looking back at this blue planet, being on the inside, looking up, looking around, getting to see the creatures who share space in the sea, getting to see that like chimpanzees, like cats, like dogs, like horses, like humans, every individual is an individual with faces. And yes, Jane Goodall changed the way we think not only about chimpanzees and other creatures, but about ourselves. And I'm here to tell you, because most of you probably have not met big fish on their own terms and been inspected by them. You think you're going underwater to watch them, and they turn out to be looking at you. It's true with, I think, essentially all forms of life. Each individual, one of the great miracles of life is the great diversity of life, coupled with the great chemistry of life, the similarity, the basic elements, stardust, if you will, that make up every living thing, make up the universe. And yet, with the capacity to have such variation that you know that no individual is like you, that you have not just your physical makeup, your chemical makeup, but your experiences make you you. I think that's true with every squid. I think it's true with every living thing, that you're shaped, of course, by your chemistry, but also you learn things as you live. One of the things I learned was using scuba, even using rebreathers, those systems that make, like walking on the moon, you recycle the air. Underwater, no bubbles are formed when you use these quiet systems, and you have longer. Essentially, with this system, I was using a rebreather, but I was 400 meters below the surface of the ocean, getting to see the creatures on their own terms with no decompression. Inside, it was the same pressure as what we're feeling here in this room. I was really given that vision. If we can wrap ourselves in a one-atmosphere container, why shouldn't we be able to go all the way to the deepest part of the ocean, where the pressure per square inch is 16,000 pounds per square inch? Everything in my body that would be compressible would be squished. Lungs, anything where there's a gas space. Fish get away with it. Many creatures do, jellyfish, because they do not have those spaces. They're essentially liquid and are basically, not quite, but almost incompressible. And getting to see the creatures there on their own terms. So, look, I'm a botanist. I'm a biologist. I'm a scientist, but I'm not an engineer. But working with engineers to be able to craft systems that can go to wherever you want to go in the ocean seemed like an idea whose time was overdue. Astronauts have engineers to help build their spacecraft. The number of vehicles able to take the likes of me where I wanted to go were simply few and far between. The Alvin at Woods Hole Oceanographic Institution, long waiting line of people, and you had to justify why you wanted to go before they'd let you go. I didn't know exactly what I wanted to find. I just, when you're exploring, you can't say what you want to find. You just want to go and look. And maybe then you can say, well, here's what I want to do. But working with engineers and with private investment, started a company, which is not what I set out to do, but it's a means to an end, deep ocean engineering, deep ocean technology, to build something that would take me where I wanted to go. Not full ocean depth, but a starting place. 1,000 meters is a pretty good start. And to be able to explore and then share the view with others. Now my daughter has taken it over with her husband and others, building undersea spacecraft, if you will. 1 person, 2 person, 3 person, and now 5 person systems, not made of glass, although that's on the horizon. Glass becomes stronger under pressure. Someday there will be glass submarines, I do predict. Meanwhile, you use what's tried and true, acrylic submersibles. There are quite a few of them available now. But back in 1980, when we began with this vision, they're a very small number, and they're still a small number. You think of the number of cars, think of the number of aircraft, think of the number of vessels, even spacecraft. We're at the beginning stages of exploring the blue part of our planet. I've had the pleasure of using about 30 different kinds of submarines, including the Russian Mir subs, the Japanese. I have not used this one. This is James Cameron's 1-person sub that took him to the deepest part of the ocean and brought him back. Only the round trips really count. And this one, Victor Vescovo, an investment banker, a businessman who has a penchant for climbing mountains and going across polar areas and into the deep sea, commissioned the development of this sub, and not only has made the descent to the deepest place, but he and about a dozen others have come back. About the same number of people who have been to the moon now have been 11 kilometers down, 7 miles down into the greatest depths of the sea. There's Cameron again. So, going myself is a joy. I wish I could take all of you, every one of you, in a big sphere to go see what it's like to get beneath the surface, to see the changes from blue to, the shades of blue you can't even name until you get into that deepest purple blue, and then it's dark. When you get below about 1,000 feet, certainly 1,000 meters, it's really dark, except for the flash and sparkle and glow of bioluminescent creatures like fireflies that look like a galaxy of life all around. I had a chance, starting in 1998, with a grant from a family in San Francisco to National Geographic. It was the Goldman Foundation, working with the agency where I served as the chief scientist, NOAA, for several years. We put together a program called Sustainable Seas, and we're able to take teachers, scientists, of course, the head of National Geographic, and others around the coastline of the United States. They had to drive. Let me just show you what it's like. Because, you should think That wasn't playing. Anyway, if I can do it, you should be able to do it. It's like getting into a car and driving off into the blue. So, today, yes, there's greater access, but nothing like access to the surface of the land and the sea. Let me just show you, I hope, this will play, taking the Minister for the Environment from Ecuador to see where he had not been able to go as a diver or as a Minister of the Environment in the Galapagos Islands. His reaction, a little apprehensive, but he got over it, especially when he realized he wasn't going to get wet. And as we approached the bottom, and it got really dark, we had lights, so we could see when this creature, a sunfish, a mola mola, thought it would have a word with a minister, whispered in his ear, and then took off. He was transformed, and I suppose the fish was too. There's so much out there, down there. I feel like those who've been privileged to be up in space, when they come back, they want to share what they've seen. I realize that because I came along when I did, and I've had thousands of hours in the blue part of the planet, using equipment that did not exist until I came along, and it's getting better all the time, with vehicles that don't have people on board, robots, autonomous systems that travel across the ocean, new technologies to explore the ocean. But at the same time, we're beginning to understand that new technologies are also being used to exploit the ocean in ways that are unprecedented. Why should you care? I mean, the ocean is out there. People live on the land. Whatever happens to the ocean, should we care about how that affects you? Should we care about the little guys, the microbes, that we only in recent times, think about the history of humans on Earth, did not even know about the existence of microbes, of creatures such as the blue-green bacterium known as Prochlorococcus, that generates maybe 20% of the oxygen in the atmosphere. Nobody knew until 1986 that that little creature existed. And now we know, now we can think about it. What are we going to do about it as we understand that life in the ocean, like life on the land, makes our existence possible? So, starting with the little green guys, providing food for this immense diversity of life. It's like a nursery of small creatures that are the larval stages of many of the big creatures, including tuna fish, corals, the cross-section of life. There could be as many as a dozen phyla of animals pictured in this one image. It's about as many phyla of animals that live on the land overall. You can see it in a small patch of ocean where the greatest diversity of life actually exists. So, photosynthesis, little guys, bigger guys, and then if you're lucky, you can be out in the middle of the food web in action. Or you could say, this is the carbon cycle in action. This is the passage of phosphorus, of sulfur, of nitrogen, the elements that make up the universe from one creature to the next. These are systems that have been in action for the history of life on Earth, at least since the last 2.5 billion years, when organisms reached a size when one could consume others. And here we are, not only looking at life in the ocean, but our impact on what is there, because not only have we treated the ocean as a place to take oil, gas, rocks, sand, life, we're using it as a place to dump things that we don't want close to where we are. The world is changing. About half the coral reefs have succumbed to our actions one way or another since the beginning of the Anthropocene, marked at about 1950, about the time I began exploring the ocean. Kelp forests have declined again by about as much. Sargassum, some of that seems to be flourishing, but that too, these are the floating golden rainforests in the Atlantic Ocean. Seagrass meadows, because they're coastal, are really vulnerable to the areas. Sharks, 90% are gone. Sharks, small, medium, and large, some are down to 1%. It's amazing to think sharks have been around for at least 400 million years. On our watch, my watch, we've been able to take their numbers, their role in the ecosystem, the ocean, to a tiny fraction of what existed. It's not just sharks, it's tuna, now being taken by the ton, so that their level of existence has plummeted to about 10%, in some cases less. Whales, we almost exterminated. I watched a half a dozen young sperm whales be reduced to oil and bone and meat back in the 1970s. But starting in 1986, about the time that Prochlorococcus was discovered for the first time, a moratorium on the killing of whales gave hope for them and for us. There's a connection between whales, between the ocean, between the melting of ice in the polar regions, such as Antarctica, and where our future and theirs intersects in the 21st century. We are now armed with looking with new eyes at creatures, whether it's a tree or a whale or a tuna fish or one another, with greater respect. In Antarctica, when I was a child, it was known that these little creatures existed, krill, but we did not think of them as something that could be taken by the ton for cosmetic reasons, for krill oil, for health. By now, on the industrial extraction of krill from Antarctica, from wildlife from the ocean, we are actually altering on a scale that connects with climate, that connects with our future. It seems unlikely that one human, one person, one species could have such a profound effect on the nature of the world as a whole. But we have the evidence, we have the witness in the times that have shifted from simply using the ocean to feed families and communities to now take wildlife on a scale that is truly altering the nature of the planet. And on the horizon, beyond what we're taking in terms of wildlife, the mining of the deep sea, the technology that on one hand gives us insight and should give us hope, is also poised to take on the depths of the ocean only now accessible. It seems, in a sense, unfathomable that we would consider taking on this deep ocean wilderness for the short-term interests that we have devised when we have yet to really explore and understand who lives there, or what their role is, or how their lives and ours connect. We have a chance right now, in this part of the 21st century, to decide whether to proceed with tearing up one of the last great wildernesses or leaving it intact for reasons that now seem obvious, to maintain the integrity of the wild systems, the natural systems, and to restore what we can of those that have been damaged. This is perhaps the last best chance we will have. The deep sea, maybe 10% has been seen, let alone understood. Creatures there that the deeper we go, the less we know, but the new discoveries that we find are astonishing and increasing. So, reasons for hope. We started this session with Jane Goodall talking about why we should be optimistic, what we need to do to respect human mind, the human spirit, the resilience of nature, to look at ourselves as we look for hope. I have been involved over the last 20 years or so trying to establish in the ocean areas that can be regarded in ways that we have protection on the land. Reason for hope around the world, nations are coming together to safeguard at least 30% of the land, at least 30% of the ocean by 2030. We better hurry up if we're going to make it. About 15% of the land is protected in one form or another. Only 3% of the ocean is highly or fully protected. The organization that I started, called Mission Blue, now has worked with individuals, with institutions, with communities, with other organizations to establish around the world 160 and growing hope spots, areas that, if protected, can become a part of this 30% initiative that other organizations are certainly getting behind, endorsed by the International Union for the Conservation of Nature. We can, no, let's say we must really take seriously the need to safeguard nature. Half of the world exists beyond national jurisdiction. Reason for hope, just within the past year. Nations have come together to endorse the concept of protection for the high seas, literally about half the world. This is the blue heart of the planet. We have a chance, but we don't have a lot of time. The last on the list of reasons that Jane Goodall gave for hope was the kids coming along. I agree. They don't come armed with the knowledge that you have, that any of us have. We have to give them not just knowledge, but hope leading to action, to give them the distillation of what has been learned throughout civilization, and to realize that never before have we been able to know what we now know, or the capacity to go from where we are to get to a better place. Imagine if we did not know. Kids are wearing pro-chlorococcus t-shirts. Where's yours? I mean, I have a fifth reason to add to Jane's. There is within every one of us that kid with curiosity, that kid really wanting to know everything about everything, that kid who wants to have a future, however many years that might entail. So, I say we are the best ever in the history of humankind, best armed, best able to go from where we are to get to a better place. I'm in. I hope you are too. Thank you.